Hello, Algebra 2. This is your Lesson 96, Joint and Combined Variations, as well as Irrational Roots. We're going to start off by talking about the types of variation. We have learned about direct and inverse variation probably since the beginning of Algebra 1, and that is using y equals kx and y equals k over x. Today you're going to have joint variation, and that is utilizing the equation y equals k times x times z. And combined variation, where you're going to have both direct and inverse variation in the same setup. It's probably a little bit easier to grasp, though, if we just go straight into some questions. So going into your ABC questions, we're going to start with A, which is actually working with irrational roots, and then B, we'll get into the variations. Question A, taken out of your textbook, page 401. We have x minus 3y equals 5, xy equals 3. Just as we have learned in this last couple of lessons that we're going to isolate that top equation, we'll get x by itself easily, add the 3y over to the other side, and then we substitute that into the second equation. So instead of xy equals 3, we're going to plug in, for x, we plug in 3y plus 5 times y equals 3. Distribute the y across. 3y squared plus 5y equals 3. Now let's subtract the 3 to the left side so we have our trinomial all on the same side. Set it equal to 0. And from here, we would check if we could factor. This is not going to be factorable, so whenever we can't factor, we use that quadratic equation. Okay, so it's actually solving for y on this one. So it's y equals negative b plus or minus the square root, b squared minus 4ac all over 2a. Let me just plug in what those values would be. Negative b plus or minus square root b squared minus 4ac all of that over 2a. Oops, let me just take that out of there. Okay, and then I'll simplify that. Inside the square root, we get 25 plus 36. All over 6. So one more step here, I have negative 5 plus or minus the square root of 61 all over 6. Square root of 61 cannot be broken down further. Okay, because this is a plus minus in the middle, just remember what that means. That is going to give us two separate solutions for y, and each of those y's will then be plugged into this orange equation up at the top. Okay, so I'm going to focus now on the orange equation. I'm going to plug in the first of the y solutions. So I get x equals 3 times the quantity, negative 5 plus root 61 over 6 plus 5. I distribute the 3, which really means I can cancel it with the 6 down below. Okay, and so that will give me x equals negative 5 plus the square root of 61 all over 2. And I still have a plus 5 off to the side. The plus 5, I'm going to go ahead and change that now into 10 over 2 so that it has a common denominator. Then when I combine them, I get x equals positive 5 plus the square root of 61 over 2. And that would be paired up with the y value -5 plus the square root of 61 over 6. So I'm going to go ahead and highlight this as a pair. And then I need to go back and address the second equation for y and plug it in to the orange equation for x. So I get, plugging in, x equals 3 times the quantity -5 minus square root 61 over 6, with the plus 5 sitting outside. And just like last time, we can cancel the 3 and the 6 and make that a 2 with its reduce. So when I rewrite this, x equals -5 minus the square root of 61 over 2, and then that's plus 5. But I'm going to change that plus 5, make that into 10 over 2, so that it can combine in the same fraction. So now I get x equals +5 minus the square root of 61 over 2. And that is going to pair with the y value -5 minus the square root of 61 over 6. And I'll just highlight those in a different color so we know that's a separate pair. Okay, so very similar to the type of questions we had a couple lessons ago. Now we're going to go to question B, and you'll want to look on page 401. It's a large word problem. The number of elk varied inversely as the number of deer and directly as the number of antelope. So I'm going to pause there, and I'm just going to make a note that we have elk, and they are first going to be inverse to deer, direct to antelope. Well, when we look straight across, that's a direct variation. So direct to antelope is going to go straight across, and varying inversely would be what's varied on the denominator, and that would be deer. Let me actually write that, inverse to deer. That's just some notes for me so that I know how to set up my equation. So I have elk varying with antelope up top and deer in my denominator, and there is always a k value, which is called the constant of variation, and that is just there to help us get the equation set up with a sort of built-in slope. Okay, now I'm going to read the rest to figure out how I'm plugging in. When there were 75 elk, there were 85 deer and 15 antelope. So I pause here and I plug in that there were 75 elk. I don't know my constant. 85 deer, 15 antelope. Okay, and then I would go through and solve for k. So I'm going to multiply the 85 to the other side. And then I'm also going to divide the 15 to the other side. Use a calculator. And my final answer I get is 425. All right, once I have that, I'm not completed with this question. I go back to that original setup and I plug in what k is. So in this case, it's E equals 425A all over D. And then I read in the paragraph what the new scenario is going to entail. It says, how many deer were there when there were 20 elk and 30 antelope? So now I plug in 20 for my elk. I'm going to plug in 30 for my antelope, and I'm going to figure out what my deer population would be. Okay, I'm going to do my trick of swapping so that I get deer equals 425 times 30 divided by 20. Grab that calculator. And when I go through and divide, I actually end up with a decimal. I get 637.5. Okay. And because we're talking about a population, we can't have half of a deer. We round down to the full number of deer that we're discussing. So that would be 637. All right, now we're going to look over into some of your homework questions. We'll start with question 1. The number of girls varied inversely as the number of boys and directly as the number of teachers. So we have girls, and they do have a direct straight across with teachers. And then there was an inverse with boys. All right, so how I would set that up is I have girls equals the teachers over the boys, but then I also have my K for constant of variation. Okay, then we look at the question to see what we're plugging in. When there were 65 girls, there were 15 teachers and 3 boys. So 65 girls goes on the left, 15 teachers, 3 boys. We'll multiply the 3 up next to the 65. And then we'll eventually divide that 15 over. Okay, and using a calculator, and I got 13 for my K constant of variation. I'm going to go back up to this original question and plug in 13 for my K value. I'm also going to check my question in the book to see what my next steps are. At how many boys were there when there are 5 girls and 100 teachers? So 5 girls, 100 teachers. How many boys are there? We can do our shortcut swap here. So B equals 13 times 100 divided by 5. Grab your calculator if needed. And then I get boys equals 260. All right. Let's carry on to number 2. Spanners vary jointly as ratchets and miters. So when we vary jointly, that means they're going to both be direct. Okay, so we have spanners as our main one, and they're varying jointly. We have both ratchets and miters. So how that would look as an equation is we would have S for spanners equals K for constant, and then ratchets and miters, RM, all right next to each other. Then we look for the question to see how we plug in. If 100 spanners went with 4 ratchets and 5 miters. So I plug in 100 for spanners, 4 ratchets, 5 miters. That is basically saying K times 20. Divide both sides by 20, and K equals 5. Next, I will take that constant and plug it into the original equation. Okay, And going back to the question in the book, how many ratchets would go with 20 spanners and 2 miters? So plugging in 20 for spanners, 2 for miters. Go through and divide, and I get a final answer of ratchets equal 2. All right. And then I would like to go ahead and do question 5 with you right now. That is a chemistry question. We have antiseptic solution. The only way to mix a 32% antiseptic solution was to mix a 20% solution and a 60% solution. How much of each should be used to get 500 milliliters of that 32% solution? So we always have our first column talking about the percentage, and it's an antiseptic solution. So I'm just going to abbreviate antisep. Or we also look at what our unit is that's given, and it's milliliters. This will be our total on the far column. Then I go to my rows. The first 2 rows are going to be the 2 things being mixed. I call them mix 1 and mix 2. The third row is always what our final outcome is going to be, the final mix. Okay, and then we pull from the question for these parts. We're wanting to mix a 32% antiseptic solution, and we want to get to that at the end of it. In other words, that goes at the bottom. That's the final mix that we're having as our goal, and it does tell us that it's 500 milliliters. Now I'm going to go back and see what are the other percentage amounts for the solutions mix 1 and mix 2. We have a 20% solution, and we have a 60% solution. We are not given the milliliters, so we're going to just name one of them X, and the other one, since we know it ends with 500, the other one is going to be 500 take away X. All right, and then we multiply across. So 20 times X gives us 20X. 60 will get distributed across 500 minus X. And then 32 times 500 will be in our final spot. When we go to set up our equation, we're adding the mix 1 plus mix 2 and equaling our final mix. So here's mix 1 plus mix 2 equals our final mix. Now I'm going to go back and distribute my 60 and also the 32 at the end. So 20X stays the same. And then 60 times 500, that's going to be 30,000. Minus 60X equals 32 times 500. That is 16,000. Let's go through and find some common terms here. That makes negative 40X equals, and I'm going to subtract the 30,000 over. That would be negative 14,000. Divide both sides by negative 40. And I get X equals 350. So what I just solved for is this right here. That value was mix 1, the amount of milliliters. Okay, so that means when I go to write my answer, I need to specify that. I'm going to say 350 milliliters, and that was for the 20% antiseptic. And then if I've used 350 milliliters, what's left out of that 500 is the part that says take 500 and subtract the 350. So for that, we have 150 milliliters left, and that's going to go for that 60% antiseptic. Okay, so those are my 2 solutions for the quantity of each of the mixes. Okay, and then recognizing 6 is new for this lesson. that's one that you are going to go on your own for. Good luck.